Okay, now, on the previous tutorial, the thing that we discussed about that was a kind of a understanding that how we can extract the uncertainty or the credible intervals from a model which is built on the Bayesian framework. And now, in our example that we're looking at the women data sets on their average height and weight, now we just want to just go ahead and just do something similar, but it's going to be the confidence interval. On the previous tutorials, we discussed about the similarities and the differences between these two from the point of the philosophical view which they have, how randomness is going to be assigned either to the parameters or the lower upper bounds of the interval, and now we just want to see that exactly how it's just going to be translated into our real physical, tangible data sets that we have. Okay. In order to do this, I need to run the function, which is going to be the confidence interval, which comes with the base package there, which is the function is going to be confint. And in order to see what kind of arguments do I need to just put as an input inside the function, inside the parentheses, I'm just going to go ahead and just press F1 and get the help menu open, and I see that for the first thing I have the object. My object here is going to be a model B, which we created that before. I have to make sure that for the confidence interval I have to use a model which has been created by a GLM method, by the generalized linear methods, or you can just use also the LM or GLM. Both should be totally fine, but you have to make sure that you just use the model B, because model B here we just use the non-Bayesian framework in order to make the best estimates for the slope and the intercepts in our linear model within the data sets which was woman. And now I'm just going to do the same thing. I'm just going to go ahead to choose the appropriate model, which is going to be the non-Bayesian. The other thing which I need, you see that here I have something, this is parms. It's essentially somehow similar in terms of the syntax, the parse that we had in the Bayesian framework. Then I'm just going to go ahead to just write parm, and it's going to be the variable which I had, which it was weight, but I have to just make sure I just put that inside the quotation mark because it appears as a kind of string to the R language. However, you will see that in the future tutorials that when we are trying to just do some kind of Bayesian or non-Bayesian regression analysis at data sets that we have more than one covariates, then in that regard it is always necessary that we specify that we are looking for the confidence interval or the credible intervals assigned to which covariates that we are trying to make the inference about the slope then. Here we have only one covariance, which is the weight. We can either just put it there or we can just omit it, but it's always a good practice to stick to the rules in case that when we have more than covariates, we know that we have to just put the covariates that we are interested to just find the credible interval or the confidence interval with it. And now I'm just going to go ahead with the level. The level in terms of the syntax is essentially like the same thing that we had in the Bayesian one, which it was prob, which we talked about the probability. Now we have the level. The same thing, we can just put 95%. It's the 95%. It's essentially the same as the default value for the level of the probability. But here on the Bayesian, we had 90%. At the non-Bayesian, we have 95%. But we can always change it, and it seems that right now we are done with all the required arguments that we had to just put as an input for the confidence interval, and now the code is ready to be executed. I just press Control Enter, and I should say, I see that I have this. And now I'm just going to run these two codes together, and now the non-Bayesian one. And you see that these ones we can just also make a good comparisons of what has happened then. You see that in terms of the confidence interval, we have somehow a kind of a similar things that we had on the very last line here, which is essentially the non-Bayesian framework, and it refers to the confidence interval. We are assigning, I should say, a fixed parameter, which is going to be our slope, within, I should say, the random, I should say, upper and lower levels, which you see that it's essentially within the regression analysis, somehow they are so close. For the non-Bayesians we had, the lower bounds, we had 0.27, 0.89. With the non-Bayesians we have 0.2723, and also the same thing for the upper bounds in the Bayesian, which we had 0.30, and also we have this one here 0.30, and it's essentially the same thing. It means that if we just do that, we do not see that much difference between the credible intervals and confidence intervals, essentially between the Bayesian and non-Bayesian frameworks at these regards. But you know that in terms of the philosophy and the interpretation between these two values, there is a huge difference. As you saw that on the tutorials, you saw that on the Bayesian, we assign a randomness to the slope as a parameter that we are just trying to make an inference within the fixed upper and lower bounds. But in the non-Bayesian frameworks, we are assigning a fixed parameter, which is going to be our slope for the covariates. We are just trying to make an inference, but we assign the randomness on the upper and the lower bounds of the interval that we are just dealing with. And now, on the next tutorials, we're just going to specifically focus on how to find the probability also if we assign, I should say, the intervals to our model, which is going to be the topic on the next tutorial.